Welcome. In this lecture, let us solve a few numericals based on the formulas and concepts which we have learned in the earlier lectures. So let us look at the first sum. Cos A minus B upon cos A plus B is equal to cot A multiplied by cot B plus 1 upon cot A multiplied by cot B minus 1. So basically we have to understand that we have to somehow convert whatever is in cos into whatever is in cot. So if you want to convert from cos to cot, there has to be a sine component which is dividing the cos component. So this is the thought process with which we start. On our LHS, we have cos A minus B upon cos A plus B. Expanding that, we get cos A cos B plus sin A sin B upon cos A cos B minus sin A sin B. Now on our RHS, we need a cot A. On our LHS, we already have a cos A. So how will we move from cos to cot? We have to divide whatever is in cos by sine. So this cos A has to be divided by sine A. Similarly, this cos B has to be divided by sine B. So what do? We divide numerator, and that is why we divide denominator by sine A multiplied by sine B. Divide numerator and denominator both by sine A multiplied by sine B. So it is dividing both numerator and denominator. So separating out the numerator, what do you get? Cos A cos B upon sine A sin B plus sin A sin B upon sin A sin B. The whole thing divided by cos A cos B upon sin A sin B minus sin A sin B upon sin A sin B. So look at this. What do we have here? Cos A upon sin A will become cot A. Cos B upon sin B will become cot B. Sin A sin B cancels. So what we have? Plus 1. Similar working on the denominator gives you cos A upon sin A cot A, cos B upon sin B cot B, sin A sin B cancelled. You get minus 1. Hence the answer. Now in this same sum, if the RHS was in terms of tan, what will we do? If RHS is in terms of tan, we divide all that is sine by all that is cos. So in that case, our numerator and would have been divided by cos A cos B, and our denominator would have been divided by cos A cos B. So we would have got an answer in tan. As simple as that. You can similarly try solving this sum from RHS, from right hand side. Convert cot A as sin A upon cos A, convert cot B as sin B upon cos B, and try the sum. You will still be able to get the answer. So you can see there are various ways of solving the same problem. Let us move ahead. Sin A minus B upon sin A sin B plus sin B minus C upon sin B sin C plus sin C minus A upon sin C sin A is equal to 0. So what do we mean is equal to 0? If we want 0 as the answer, either 0 should be a multiplying factor or each term should cancel out. 0 should be a multiplying factor or each term should cancel out with some other term. So let us check. What is our first term? Sin A minus B upon sin A sin B. So sin A minus B formula we know. sin A cos B minus cos A sin B. Sin A cos B minus cos A sin B, whole thing divided by sin A sin B. I am just focusing on the first term right now. So I separate out the denominator. What do I get? Sin A cos B upon sin A sin B minus cos A sin B upon sin A sin B. So sin A will cancel. Sin B will cancel. What do you get? Cos B upon sin B will become cot B. Cos A upon sin A will become cot A and minus sign in between. So you work out, this is a pattern. The first term gave us an output cot B minus cot A. The second term by the same pattern should give us an output cot C minus cot B. You can see the working here as well. The third term should give us a pattern cot A minus cot C. So if you look at it in a way, cot B gets cancelled with cot B, cot A gets cancelled with cot A, cot C gets cancelled with cot C. You get the answer as 0. Let us move ahead. Mark this sum as interesting, important sum. So what do we get in this sum? Cot A plus B into cot A minus B is equal to cos square B minus sin square A upon sin square A minus sin square B. Sin square A minus sin square B. So let us look at our left hand side, that is cot A plus B multiplied by cot A minus B. So what do we get here? Can we write cot A plus B as cos A plus B upon sin A plus B? Perfect. Cot A minus B as cos A minus B upon sin A minus B? Perfect. So cos A plus B upon sin A plus B, can I write it as cos A cos B minus sin A sin B upon sin A cos B plus cos A sin B? There is a multiplication in between. Cos A minus B will be written as cos A cos B plus sin A sin B. Sin A minus B will be written as sin A cos B minus cos A sin B, and everything is multiplied. So you can directly multiply numerator with numerator, denominator with denominator. So now look at what do we have in our brackets. Cos A cos B minus sin A sin B multiplied by cos A cos B plus sin A sin B. Can you see a link there? A minus x minus y into x plus y. If you take cos A cos B as x, sin A sin B as y, will we get x minus y in the second bracket x plus y? So what is x minus y into x plus y? It is x square minus y square. Similarly for your denominator, please look at your denominator. The same concept applies there as well. So what will we have? We will have cos A cos B multiplied by cos A cos B as cos square A cos square B. Sin A sin B multiplied as sin A sin B as sin square A sin square B. Here sin square A cos square B minus cos square A sin square B. Now at this moment we pause and look at what we want on our right hand side. So if we look at what we want on our right hand side, we want a cos square B. So have we got it? I'll just remove these things. That will make it easier. So have we got a cos square B? Yes, we have got a cos square B. Have we got a sin square A? Yes, we have got a sin square A. In the denominator sin square A? Yes, we have got a sin square A. In the denominator sin square B? Yes, we have got a sin square B. But then there are these extra terms. The extra term is cos square A here, sin square B, cos square B, cos square A. We don't want these terms. So when you want to remove these terms, one method that you can use is divide numerator and denominator by that term. You can try out separately. You will see that it doesn't work out perfectly for this sum. Then we have to do sum out of the box thinking. Can I write my cos square A as 1 minus sine square A? Can I write my sine square B as 1 minus cos square B? Can I write my sine square A, sine cos square B, sorry, as 1 minus sine square B? Can I write my cos square A as 1 minus sine square A? So your sum becomes 1 minus sine square A, 1 minus sine square A into cos square B minus sine square A into 1 minus cos square B, whole thing divided by sine square A into 1 minus sine square B minus 1 minus sine square A into sine square B. So now let us start multiplying. Cos square B multiplies to 1 becomes cos square B. Cos square B multiplies to sine square A becomes minus sine square A cos square B. Sine square A multiplies to 1 and becomes sine square A. Minus sine square A multiplies to minus cos square B and becomes positive sine square A cos square B. The same working you can do in the denominator. Now you will find minus sine square A cos square B plus sine square A cos square B eliminates. Minus sine square A sine square B plus sine square A sine square B eliminates. What remains? Cos square B minus sine square A upon sine square A minus sine square B. Hence the answer. Please try to solve this sum without looking at the solution. Lot of concepts in trigonometry will start getting clearer. Let us move ahead. Now a sum for practice. Prove that tan A plus B upon cot A minus B is equal to sin square A minus sin square B upon cos square A minus sin square B. So hint, cot A minus B, 1 upon cot A minus B can be written as directly tan A minus B. 1 upon cot A minus B will be written as tan A minus B. Try to solve the sums. Second step will be convert all that is tan into sine and cos. So sine A plus B upon cos A plus B. Do not go for tan ka formula. Multiplied by sine A minus B upon cos A minus B. Expand and try to solve the sum. The method will be very similar to what we did in the last sum. Hope you have got the answer. Now let us move ahead. Tan phi A minus tan 3A upon tan phi A plus tan 3A is equal to sin 2A upon sin 8A. So again, what should be the start of the thinking process? On my LHS, I have got everything in tan. On my RHS, I have got everything in sine. So everything that is tan, I convert to sine. So tan phi A will become tan phi A can be written as sin phi A upon cos phi A. Tan 3A can be written as sin 3A upon cos 3A. So what do we get? Sin phi A upon cos phi A minus sin 3A upon cos 3A, whole thing divided by sin phi A upon cos phi A plus sin 3A upon cos 3A. Next step is cross multiply. Simply cross multiply. So what do we get? Sin phi A multiplied by cos 3A minus cos phi A multiplied by sin 3A upon cos phi A multiplied by cos 3A. whole thing divided by sine phi a multiplied by cos 3a plus cos phi a multiplied by sine 3a upon cos phi a multiplied by cos 3a. So we can easily eliminate the denominators. What remains? Sin phi a cos 3a minus cos phi a sin 3a. It is the formula of sin a minus b. So I write it as sin phi a minus 3a. Sin phi a cos 3a plus cos phi a sin 3a. It is the formula of sin a plus b. I write it as sin phi a plus 3a. So what will be phi a minus 3a? Sin 2a. Phi a plus 3a sin 8a. Hence proved. Let us move ahead. Have a look at this sum. Cot a cot 4a plus 1 upon cot a cot 4a minus 1 is equal to cos 3a upon cos 5. Again we use the same logic. On our LHS we have cot everything in cot. On our RHS we have everything in cos. So convert cot to cos. You can do that as cos a by sin a. So cot a becomes cos a by sin a. Cot 4a becomes cos 4a by sin 4a. Next step, you have cos a cos 4a upon sin a sin 4a plus 1. So treat it as x y upon pq plus 1. So what would you do in that thing? In that case, xy plus pq upon pq. So similarly, sin a and sin 4a will come here. So you will have cos a cos 4a plus sin a sin 4a, whole thing divided by sin a sin 4a. In the denominator, cos a cos 4a minus sin a sin 4a upon sin a sin 4a. So sin a sin 4a sin 4a cancels. Cos a cos 4a plus sin a sin 4a is cos a minus 4a. Cos a cos 4a minus sin a sin 4a is cos a plus 4a. So we actually get cos minus 3a upon cos 5a. So one formula to remember, write it down. Cos of minus theta is equal to cos theta. Sin of minus theta will be minus sin theta. So additional knowledge here. So you get the answer as cos 3a upon cos 5a. Please try this sum. Cot 6a minus tan 2a upon cot 6a plus tan 2a as cos 8a upon cos 4a. The hint that I will give you is convert cot and tan of whatever angle to cos upon sine and sine upon cos. Once you do that, the sum will become solvable. Please try it. Hope you got the sum. Now some pretty important sum for your college exams as well. Tan 8a minus tan 5a minus tan 3a or tan 8 theta minus tan 5 theta minus tan 3 theta is equal to tan 8 theta multiplied by tan 5 theta multiplied by tan 3 theta. So when a sum like this comes, the first thing we have to think is why these numbers are given in this way. There has to be some arithmetic link between the numbers. So if you look at the numbers come out as 8, 5, 3. Numbers come out as 8, 5 and 3. So is there a mathematical link? Yes. 8 is equal to 5 plus 3. 8 is equal to 5 plus 3. So tan 8 theta, can I write it as tan in bracket 5 theta plus 3 theta? 5 theta plus 3 theta. Perfectly. So can I use the formula of tan A plus B? Tan A plus B. What is that formula? Tan A plus tan B upon 1 minus tan A multiplied by tan B. Applying that here, tan 8 theta will be tan 5 theta plus tan 3 theta upon 1 minus tan 5 theta into tan 3 theta. This denominator we move to tan on the LHS multiplied with tan 8 theta. So tan 8 theta multiplied by 1 minus tan 5 theta into tan 3 theta. On your RHS, what will come? Tan 5 theta plus tan 3 theta. Open the bracket, what do you get? Tan 8 theta into 1 is tan 8 theta. Tan 8 theta into tan 5 theta into tan 3 theta will be tan 8 theta, tan 5 theta, tan 3 theta is equal to tan 5 theta plus tan 3 theta. Now, move this term and this term to the left. Move this term which I am marking in green to the right. You will find you have got your answer. Tan 8 theta minus tan 5 theta minus tan 3 theta will be equal to tan 8 theta into tan 5 theta into tan 3 theta. Please look at what we have done. Simple tricks and simple adjustments will give you the answer. Tan 18 plus tan 27 plus tan 18 into tan 27 should be equal to 1. Again, the first thought that should run in your brain is why the numbers are given in such a way. So is there an algebraic link? 18 plus 27 gives us 45 and we know tan 45 is 1. So there must be some relation with tan 45. Let us look at it. Tan 45 can be written as tan 18 plus 27. So apply the formula of tan A plus B. If you do that, you will get tan 18 plus tan 27 upon 1 minus tan 18 tan 27. Move this thing on your LHS. Tan 45 in bracket 1 minus tan 18 tan 27. So there should be one more bracket here which will make it clearer, is equal to tan 18 plus tan 27. Open the bracket. Tan 45 into 1 will be tan 45 minus sign as it is. Tan 45 into this bracket is tan 45 tan 18 tan 27 is equal to tan 18 plus tan 27. What is the value of tan 45? 1. So this becomes 1 which is not shown here. So 1 minus tan 18 tan 27 is equal to tan 18 plus tan 27. Move this term on the right hand side. Move this here. It will get added. There is a negative sign here. So on this side it will become positive. So 1 is equal to tan 18 plus tan 27 plus tan 18 into tan 27. Hence proved. The trick here was to identify tan 45 as tan 18 plus 27.